In this video we will look at forces and in particular their behaviour whilst in equilibrium. Now a force will cause something to accelerate. It'll also cause things to deform. Now if there is no resultant force, i.e. very simply 5 newtons acting in that direction, 5 newtons acting in that direction, there will be no acceleration at all, and no deformation, no resultant force. Okay, now let's have a look at this. So let's imagine a book falling. Here's a classic book, big, heavy, old-fashioned style physics book that is falling heavily due to its weight acting down, so it's being attracted to the earth. Now let's assume there's no air resistance. In that case there, even if there was air resistance, but ultimately it is the unbalanced forces. Okay, it's unbalanced, and it will accelerate. It will accelerate, again unheated by air resistance, until it reaches something like a table or a desk, whereupon it will hit the desk. It may deform slightly and spring back again. It may bounce, but within a short period of time it will be resting on the table. Its weight will still be acting down, like that. However, there must be an equal and opposite force acting up. We'll call that the reaction force. Now, if the weight of the book was equal to, say, 4 newtons, then R clearly must be equal to 4 newtons. Now be careful here. At this stage, if you're taking R and W to be vectors, which they look like, they have both magnitude and direction, then you cannot write R equals W. But what we could say is that the magnitude of R equals the magnitude of W. Now we don't always need to write magnitude like that, but that's just bear that in mind. So you could say R equals W is equal to 4 newtons. They are in equilibrium, they are balanced. Another situation where they are balanced is, for instance, well, let's bring in air resistance. If you had some chap who is skydiving, and I'm going to give him a parachute. Well, if this chap has a weight of 700 newtons and the air resistance acting up due to his the air resistance of his parachute, basically when it's the velocity is greater, when its air resistance is also equal to 700 newtons, again the forces are in equilibrium and the acceleration will be equal to 0. Now he may well have a velocity equal to, perhaps, I've got no idea, I'm just guessing. Say his velocity at this stage is 7 meters per second. Now that may be a bit fast, as it hits the ground it could hurt a lot, but we'll change that down to something more reasonable, say 3 meters per second. He could still be moving with a velocity of 3 meters per second, but he's in equilibrium, they're balanced, and the acceleration is 0, so the resultant force is equal to 0. Okay. Now, let's bring a little bit of mathematics into here. Not too much. So, let's have a block on the ground, and let's have a force. Somebody's trying to move this block, suitcase, or whatever it is, but we'll represent it as a block, an object, and they are pushing with, pulling with 30 newtons and at an angle of 25 degrees to the horizontal. So there will be forces acting up. So there will be weight acting down. There will be the reaction force, the weight acting up. But what we're going to do is we're going to, and there will, of course, is going to be some friction acting in that direction. Now, say we wanted to find out what the friction was. Because F and R and W, they are mutually perpendicular, there's no component of R in the direction F, so we can totally ignore the forces perpendicular to F. And this is why it's so useful to draw forces at 90 degrees to each other. So if, for instance, that is moving at a constant velocity, we're dragging this suitcase, block, whatever, at a constant velocity, we know therefore that the acceleration is 0, the resultant force is 0. So what we could write is, we could say that F, to balance, F, the magnitude of F, rather, F is equal to 30 times the component of 30 in that direction, so it'll be F times the cosine of 25. You remember in vectors, it's the cosine, the cosine of the angle times the force gives us the component, so that the friction is 30 times cos 25, so the friction equals 30 multiplied by, now the cos of 25 is 0.906, so the friction will be 27 newtons.